Hi guys, welcome to Tech Geek. So today we'll be discussing the solution for the Leetcode medium problem, that is for find first and last position of element in a sorted array. So basically what we need to do is we have been given an array of integers in non-decreasing order, that means in ascending order, and we need to find the first and last position of that particular target element, and we have to return the positions for that. Okay, and if the target is not found, we need to return -1. That means basically an array of size 2 should be returned. That is the very first thing. Then what we must keep in mind is that okay you must write an algorithm with order of log n. Okay, that is the basic constraint that we have been given. Now let's see an example. We have an array of 5, 7, 7, 8, 8, 10, and the target value is 8, right? So let's see with this array, just a minute. Yeah. If we talk about the array 5, 7, 7, 8, 8, and 10. So that is the first. If we traverse the array from here, so what we will get is, right? If we traverse the array, this is index 0, 1, 2, 3. This is the first element, that's the target element is matching. So the first index is 3. So the first element, that's result or answer of 0, should contain 3. Now if we traverse the array from back, so this is nums -1, right? The size of the array is 6, so this would be 5. Again comparing and then coming to 4, that's matching, that's the last one. So this should go with the second element, right? So now coming to the fact, like how should we go up so that it comes up with order of log n, right? Not even order of n, it should be order of log n. So what should basically be our method? So let's see. We all know in searching, that's the very first thing we need to do is to search for that particular element, right? Now we have to search for that element. That means we should go with the basic searching. There we have linear and binary. So according to us, we know that order of log n is the time complexity we need to keep in mind. So what we would do is we would take up with binary search, right? Binary search, the time complexity is order of log n. Okay, so this is the basic constraint we have, that order of log n should be our time complexity. So we'll go with binary search. Now the target element, this is another array that I've taken. So the target element for us is 5. So what we will do is, now we have three things. Okay, we have 3, 5. So we need to take the first and the last one. Now how this will happen in the, binary search, because in binary we take the middle element, right? So somewhere we need to check how this would go up, right? In binary we have three constraints. We take L as 0, H as number of elements -1, right? And for the middle one, we compare whether that is equal or not. Let's go off with the dry run of this particular. Okay, so let's mark the indexes first. This is 2, this is 3, this is 4, and this is 5. Okay, so the length of this particular array is 6. Now low should be 0, high should be 5, right? Now talking about mid, 5 plus 0 by 2. Okay, so this will come up to 2. This is the middle element. Now we'll compare if middle is equal to target. Yes, it is. Now we won't return this directly. We need to check whether this is the first element, last element or not. I hope this is clear, right? What we would do is, now we will check the one to the left. As we are searching for the first element, we'll check for the one to the left. If the element in the left is equal to 5, right, then we'll make high as 1. That's middle -1. but in this case it wasn't, right? So we saw that it is not equal to 1, right? Sorry, it's not equal to target value. So we got the first one, that's the resultant of 0, as the index 2, right? That's the first element is found now. Once the first element is found, we know we need to search for the last one. Let's see, uh, the k was 6. If in this case, then obviously there was no element, then resultant of 0 would still remain -1, right? So in that case we won't go for the second one. We have to keep in mind, if we find the first one, then only we should come with the second one, right? Now we'll search for the second one. Okay, first is fine. Now again we'll go traverse the array. Now in this case, for finding the second one, again the things would go same. That's L is 0, M is this, and then H. We found that target element is equal to, mid element is equal to target. Now we need to find the last position. So what we need to search, the element towards the right. Is the element towards the right? That's, let's say if the array was A of mid is equal to A of mid plus 1. I hope this is clear. What we'll check for the one to the right, because we need to take the highest position. Okay, please ignore my writing in this case. Okay, now we'll check this is equal, yes. So what we will do, we'll make low as m plus 1. Again binary search goes on. 3 plus 5 by 2, that's 4. Again this comes the mid. Is mid element equals to target? Yes. As we are searching for the last position, again we'll compare with this one. Is it equal? No. If it's not equal, then this would element, this particular index would be stored. Okay, this particular index would be stored in our res1. So the resultant array now we have is 2 and 4. So basically we are using a modified version of binary search. What we need to do is search for the element, the first position, that's the first position, but keeping in mind that it should be the very first occurrence. So what we'll do, we'll check if it is equals to mid. For the left one, we'll compare the mid by mid minus 1, and if it is for the last position, we'll compare it for the next element, that's mid plus 1. Now let's see what the code will be for this particular question. Okay, so this is the question that we were doing. We need to search for the range. We had nums array, we had a target. Again, answer is -1 -1. We'll store, that's the original, we'll return -1 -1. Now answer of 0, that's the first occurrence. We'll first search for the array, and this I've used one thing, that's true and false. Why is this? This is to know whether it's the first occurrence or it's the last occurrence. So true in case of if it's the first, or you can say from start, and false means from back, or it's the last occurrence, you can say that. Okay, now for the first one, first we'll check whether if it appears or not. Again we'll come to this binary search where we need the target, the first start, that's whether it's from the start or from the end. We took an initiator that start, end, that's low and high similarly. Answer is -1 for now. This answer totally different because they are local variables for the function, so please don't get confused. Again we'll implement the concept of binary search. Now in this concept of binary search, we compared whether it's less. If that particular element is less, so we'll move towards the, sorry, if the target element is greater, so we'll move towards the right subarray, and if it's less, then we'll move towards the left subarray. This goes the same, but if mid is equal to target, then what should be the condition? Okay, First, we'll keep the answer as the middle index. Again, we'll check whether the boolean that's whether it was from start or whether it was from end. So what we'll do is we'll check this, the find start. If it was from start, so we have to move towards the left subarray, so we'll make end as mid minus 1. If we have it from the right, that's the last occurrence, and we'll move towards the right subarray. So this is basically what we'll use. As we are using binary search, so overall the complexity is order of log. If any one of you is having any confusion in this particular concept or algo, please let me know in the comment section. And yeah, please keep that in mind. I've used this condition whether if answer of 0 is equals to minus 1. Why? If we don't even have the first occurrence for that particular element, how we will have the last occurrence? That means the number does not even exist. We do not need to search for the last position again. That is something you must keep in mind. That is why we are placing this condition. Okay. Thank you guys for following TechGeek. If in case you have any confusion in this, please let me know. Okay, I'll show you one more thing. I've used this code here. Let's submit this and check the time complexity. Yeah, I already submitted it in some time. Okay, you can see it's accepted. It's 100% faster than all the Java solutions there. So I hope this is something you must give it a try. And if in case you have any queries regarding the algo, please let me know in the comment section, and any other question you want me to share the solution of, I'll be happy to do that. Thank you. Keep following TechGeek.